Hello, my name is Greg Howell. I was a co-founder of the Lean Construction Movement along with Glenn Ballard, Lowry Koskela, Stan Bertelsen, and Iris Tomlin. The five of us worked together, I think, in an interesting and long-term relationship to develop what we now call lean construction. There certainly are hundreds of other people who were involved and helped us test and develop those ideas, who held strong conversations with us, and who brought us to where we are today. So I think the word co-founder must be even with a small c to recognize the larger number of people who really made this industry movement possible. I'm going to speak to you today about the development of lean construction, and I'll give you a way to try and think about and frame it in the world. I'm using a computer here that I'm going to try and also make a video of this, and so if I stumble a little bit, you're right, I'm a little confused. So, all projects, I want to frame the discussion about projects in general. Projects always have at least three, I'll call them domains. One of them is commercial terms, that is the way the money is spent and how it's organized. In the United States, typically there's in traditional practice, each one of the trade contractors has a contract with the general contractor who then manages the work for the owner under a contract. Projects also have organizations, that is the authority and communication protocols, the extent to which they rely on command and control or on a more synergetic or cooperative, collaborative nature. Organizations swing between those two poles, and we'll talk a little bit about that. And finally, all projects have what I'm going to call an operating system. There's Windows operating systems and Mac operating systems for computers. In construction, the operating system of traditional practice has been based on the critical paths method. It is a scheduling approach that is designed to tell us when to do each one of the activities in the project. The current practice is coherent. That is, the activity-centered scheduling is coherent with the commercial practices of subcontracting and the organizational practices of command and control. All projects also have a strategy, and the strategy of traditional practice is optimize each piece to optimize the project. So you break a project into pieces, assign the pieces to different entities. Each one of those gives you the lowest price they believe they can do that work for, and then each one goes to work to try and complete their work within the price they've given. And if they can make more money than that, they will, and they may do their work in a way which actually is disruptive to the larger project because it may be out of sequence or not completed to the standards that were originally applied to be applied at some point in time. So to frame this distinction then between traditional practice and lean construction, I'm going to use the model put forward by, I'll call it the OAR model. And in this model, I'm saying that we're all observers in the world. I'm a civil engineer. I was born and raised in the United States, so I have a perspective of that. I'm also a father and a husband, and so I see the world through those kinds of lenses. And we're each observers in the world. We tend to believe everybody sees the same world we do, but that rarely is really the case. You can discuss that with my wife. So here, what I'm saying, we're all observers in the world. We see it as we see it, and because of the way we see it, we take actions and we get results. So the observers in the world take action and we get results. Now, if we don't like the results, we take new actions, and we call that learning, and it happens all the time. We try something, it doesn't work, we try something else. Occasionally, something happens which changes how we are observers in the world. And that's certainly what happened in Toyota when Engineer Ono was given the task of 3 years to revolutionize the design and production of Toyota cars at the end of the Second World War, or early in the 50s. And so what happened to us is I'll say those who are in the lean construction community, is we've changed how we see and understand the world. And I'm going to try and explain that to you in our time here together. First, I want to make a really interesting case that came up recently from the Engineering News Record, a magazine in the United States. And they did a large survey, and they surveyed practitioners that were in traditional practice and practitioners who worked in lean construction. And the first slide we see here is the efficiency of current practice according to lean construction. That is, the efficiency they think of their current practice, how efficient their practices are. And they say that current lean practitioners say that their practices are inefficient or highly inefficient. That is, that the way in which they're doing their work is not very efficient at all. If you poll the other group, the people who are in traditional practice, the non-lean practitioners, they will say that their practices are in fact relatively efficient. Instead of 64% or whatever it is of lean practitioners who say their work is highly inefficient, people in traditional practice, only 14% of them believe that their work is highly inefficient. So we're looking in a sense at the same world, but the practitioners think that they're very efficient, but the lean practitioners say, no, actually we're not very efficient. Even those that are practicing lean construction, because they realize now how much more they have to learn and how much more opportunity there is available for them. Here are the two charts together. The lean practitioners on the left, in the red you can see there, 62% say that they're efficient, or excuse me, they're highly inefficient, and on the right it's 14% of people in traditional practice say that only 14% of them report being highly inefficient in their practices. So this is where we live. We have different models in our minds of construction, but this is a classic kind of tough construction project. It's the overhead space in a hospital. You can see here that there are various kinds of fluids. There are heating and ventilating facilities, lots of electronics, lots of all kinds of materials that are up there above ceiling, and this is very complicated to put in and has to be done in a very careful way to meet the high standards of healthcare. But you can also see it's very complicated, and imagine each one of the trades, the different trades then working together in that overhead and how they might coordinate their action together. So let's talk about inventing lean. I've tried to set the stage for lean. So we can trace the development of lean all the way back into the original productivity improvement movement that began you can go back even to the last century, but the century before this, I guess, as far back as in the 1900s, and see efforts in construction to improve productivity, particularly of workers or crews. As late as the late 50s in the United States, that's really when we can begin to see a shift. And that shift occurs when John Fondal at Stanford prepares a piece of work for the U.S. Navy on the use of the critical path schedule in construction. And he develops that and it becomes a powerful tool used throughout the industry. The faculty then were asked about what came next, and they said, well, now that we understand how to manage time, why don't we focus on managing cost? And cost was understood primarily as the productivity of crews. And so the study and work began to shift to looking at productivity of crews. I was fortunate to have been at Stanford at the time and became involved in the early studies of going out and looking at crews and trying to understand how they did work. It wasn't time and motion studies. It was about trying to understand the way work was organized. Along in that productivity improvement movement, in 1979, I meet Glenn Ballard on a productivity improvement program on the Chocolate Bayou project in Alvin, Texas. And Glenn and I become friends. Glenn is a great book scholar. He also has a PhD in civil engineering now, but his background is fundamentally very deep philosophic thought. And Glenn and I stay friends. We work on the problem of productivity and how to think about that. And along the way, Glenn asks the question, how well does planning work? Never actually thought about it that way, never had taken a measure of it. We know no measure that's taken particularly of CPM planning performance, but rather we look at if things are going wrong, we look at the people doing the work rather than the tool of planning being used. Glenn asked a different question, how well does planning work? And so we spent some time, maybe years, thinking about that, And he finally came up with the idea of measuring how well planning worked at the assignment level, that is, where the foreman gave assignments to their crew. So we went out and we measured that. We went out and took weekly work plans. I'll show you one in a moment. And we asked people what they were going to do next week. And we came back at the end of the week and we measured that to see what percentage of the tasks they had completed. This is not earned value. So what we were doing is saying what percentage of if you had 10 tasks last week, how many of those did you complete? And by complete, we meant complete so that they could be handed off to the next task. It might be within that crew or within another crew. So if you had 10 doors to hang and you got 8 of them hung, we would say the task was not complete because we did not finish it to the criteria established at the beginning of the week. So we're measuring the ability of the planning system to predict the condition of the project 1 week in advance. The answer was 54%. 54% of the tasks that people say they're going to get done next week, they actually get done on typical projects. The number ranged from as low as 35 to high up in the 80s. But the number 54% seems like a very common number found around the world. Can't say what it is on your project, have no idea. I'd urge you to go out and measure that and begin to think about what the implications are. For us, we realized that if we could identify what the tasks that weren't getting done, then we could look at what was not getting done and we could improve them. So we began to do a kind of plan, do, check, act approach on the planning system itself. And to do that, we had to decide what were the criteria for a good assignment. And they were pretty simple. They should be sized to the capacity of the crew. They should be in the right sequence, so we're not doing work out of sequence that requires rework or involvement with some other crew that inhibits our work. And they should be sound, that is, the assignment should be sound. The crew should have the wherewithal necessary to complete the task in their hands when they go to work. And finally, we should be able to learn from the experience. So we wanted to make a claim for what we were going to do at the beginning of the week and then see how well we were able to do it, and then use that tension to see how we might improve our performance. The next slide is an early slide. This is a slide I was taken on a large refinery in Venezuela, and what we're looking at there is the productivity, the weekly productivity of the crew. Up is bad. That is, they're not getting as much done. Low is good. And you can see that the weekly productivity is bouncing around there for about the first half of that graph, and the project-wide productivity is getting worse. You can see it beginning to go up. That's the slant of that line going up that's saying our productivity is getting worse. Right there where the note is we began making quality assignments, those that achieve those standards, you can see that the productivity of the crews dramatically increases there. You can see the number of drops down on this slide. I know it's confusing because of the sign convention, but what we see then is that when we could make good assignments, the productivity of the crews was both higher and more consistent. So that was one of the earliest confirmations that we really were on the right track. So this led us to develop a more careful planning mechanism. So this is a weekly work plan. It's a little difficult to read, but it's a 1-week plan for a foreman on a project. It's a silicon chip manufacturing plant. And you can see the tasks that are going to be done are down the left side, and the spread of who's going to do them on what days across, and then were the tasks completed or not. And if you look down the right-hand side, you can see done or not done, and if they are not done, there is a reason that they were incomplete. And then down at the bottom left, you can see workable backlog. Workable backlog are tasks that could be done this week that are ready, but are not necessary to be done this week because we don't need them until some other time. But it's a way we could keep the crew busy if we had a failure in our planning system. The most interesting one on this is the one about it's partway down, about halfway down. It says, did they get a task done? It's the 1, 2, 3, fourth one down. Did they get a task done? And the answer is no. And the why wasn't it completed? And the answer was the grooved couplings were shipped late from the warehouse. Well, that sounds like a good reason not to get something done. But we begin to ask 5 whys. We say, well, why were the grooved couplings shipped late? And the answer was, it turns out that those couplings were supposed to have been ordered by the foreman, Philip, and he had failed to order them on time. And so when he reports that the task was not done because the couplings were late, he doesn't say, I made an error. He said the error was made somewhere else. But by digging into that, we find out that he made that error, and we can go work with him and figure out how we can prevent that error from happening again next week. So as we're working along then, we learn how to make a good assignment, but we don't really know if we're making the right assignment. And that is the assignments that progress the job. And our problem then was that the critical path schedule at the level of detail we were working was rarely in a good enough condition to really help us make assignments that met our own criteria. And so we invented a kind of intermediate level of planning. We call it pull planning, and it looks like this. This is where we bring together the different trades that are, for example, going to be working up in that overhead space to look at how they're going to do the work together. And here you see an example of 3 different supervisors working on a sticky wall, trying to plan. In this case, they're installing an MRI in an operating hospital. Nobody in the hospital likes to have you in there, but we're trying to install this new piece of equipment, and so we have to be very careful about our planning. And so there becomes a kind of discussion then between the critical path schedule and this pull planning. We use pull planning because we think of pull as a request. So we go to the milestone that's to be completed, and we stand and look back down the chain from the milestone and say, okay, for me to complete this milestone, I need you in the blue shirt to do this. And the man in the blue shirt says, well, for me to complete that task, I need the fellow in the white shirt to complete this task. And so we work backwards in that sort of we might, in scheduling, think of it as a backward pass. But here we're working backwards to identify all of the wherewithal necessary to make sure that we can do the job. Here's a larger summary picture of the last planner system. There's CPM, a master schedule that helps informs our pull planning. We understand there's some tension between what's actually going on the site and the CPM. And then the pull planning leads to a look-ahead plan where we begin to organize the wherewithal to do the work. And that leads to then weekly work planning. I use the same one from Philip there as an example. And then by measuring our ability to do what we say on the weekly work plan, we can record our performance, and we can take action in any of the areas which need to be improved. In this case, you can see that as they begin to record the average percent plan complete, it developed and went from a relatively 50% range up to a 70 or 80% in a relatively short time. And you can see sometimes they have good luck and bad, things go better than worse, and so on. But that gives us a whole view of the planning system. Here's another view. I like this view because this idea of planning as conversation. And so I use these egg shapes here as to illustrate the idea of a conversation. And they're interlocked, that is, each of these conversations are connected to the other. And so there are 5 connected conversations. The first conversations are what should we do? Then there are conversations about what can we do? Finally, what will we do? And then an examination of what we completed, what we did. If you go down so the master scheduling sets milestones, and the milestones and strategy identify the long lead items. The phase or pull planning specifies handoffs between the different trades and identifies any operational conflicts. You can't stack that wood there because I'm going to dig a trench through that area on Tuesday. And then make-ready work is where we assemble the wherewithal, maybe into, call it, work packages, so that the work can be done. And then we make, now at the weekly work plan, we understand the weekly work plan as a promise. The plan I'm making for my crew is a promise I'm making to your crew. What seems to make this system work better is if that promise is made verbally and in public, person to person. And instead of dealing with some far-off entity, if I promise you I'm going to meet you in front of the theater at 10 o'clock, then that personal promise is very compelling. So then finally at the bottom we have the learning loop, and here we measure our planning system performance, and we act on reasons to failure to keep promises so that we can get better at doing what we're doing. So this leads me to one of the conceptual underpinnings of lean construction. One of the first ones we ran into was the idea of the effect of dependence and variation on system performance. And you can read about that in The Goal by Goldratt. It's a book about that, and it's where we, I'll say, stole the game. We call it the Parade of Trades, that we look at the effect of dependence and variation on system performance. By reducing the variation in the system, our performance goes up. All right, another conceptual foundation is called the language action perspective, and that's what we'll look at here in the next slide. The language action perspective, there are 5 actions that we take in language. I was asked to make a presentation to deliver there in Russia, and I was asked to come make that, but I was unable to do that for personal reasons, and so we negotiated and I made a promise. And so the customer there asked me, made a request, said, Greg, would you come here? And I said, no, I'm afraid I'm unable to do that, but I would be glad to offer to do this. So there's always a customer, there's always a provider, and all business starts with a request or an offer. There was a request, I countered with an offer, and then I went to work to prepare for the presentation. And I did some negotiation about how long, what kind of media, and so on, and finally I made a promise and said, I will do that. I think I'm a day late right now. And then I went to work building that presentation, the one I'm doing now, and in a moment I'll be done and I will say, I'm done. Now, if this were on a construction project, I'm the workforce and I'm saying I'm done, then I would make a declaration, I'm complete, and that might trigger the quality control people to come look at the work, or it might release the next crew to do their work. We need to understand that. What is it that releases the next work? And so I've talked about 3 of the actions in language actions. Request, offer, flip sides of the same coin. Promise, I commit, making a promise is another. A third one is a declaration. Only the person that makes the promise is the person who should be in the position of declaring complete. All right? And so then the other 2 are very interesting. That one is we make our opinions in language. Opinions are never right or wrong. They may be more or less well-grounded, but they are not fact. And many people like to speak their opinions as if they are fact, but opinions are opinions. Facts are, we can't assert a fact, that's the 5th action, we can assert a fact. The fact is, I'm giving this presentation in my office at 101 Alpine Drive in Ketchum, Idaho. And I can demonstrate that to you. We can walk around in the front of the house and you can see the street sign and you can see my address and you can say, yep, that's where you are. And so I can prove the factness of that claim. All right, so that's an essential idea, is instead of now, this is different than command and control, right? This is where the parties actually have a voice here, and so we want our foreman in planning to have the ability to say no rather than make a bad assignment. Okay, so here's a summary of the development. We discovered the obvious. Workflow on projects is unreliable. We invented the last planner. We developed pull planning to connect weekly plans to the master schedule. We reinterpreted pull planning as production system design. When we began to look at it that way, we began to realize about the logistics and the coordination to bring the wherewithal to the site was an important and overlooked aspect of the critical path schedule. we developed the IPD and IFOA. IPD means Integrated Project Delivery, and IFOA means Integrated Form of Agreement. These, we did this when we realized that our inability in traditional practice to move money across commercial boundaries limited our ability to innovate. And so, and if we could begin having people to collaborate in the planning, then we might find ways of improving the performance that would cause us to, in traditional practice, write a change order or have some other administrative function. But by having an integrated thing where we're all in the same contract together, then we don't have to have that, and we can move money around and maximize performance for the whole project. So we also then began to use another tool from the industrial world called target value design. It was in non-construction, it's usually called target cost, but we called it target value in construction because there are many values that have to be achieved in project delivery. And so what really powers this set of approaches is to do target value design, where you bring together the different parties early in the design phase and set them, agree on some budget that they then are going to design to, so the budget becomes a constraint on design rather than an output of design. So each one of the sub-disciplines, for example, mechanical and electrical and so on, may come forward with a number of partly worked alternatives and then meet with the other teams and figure out what are the best combinations of alternatives that will deliver what is of value to the client and minimize the cost and danger of doing the work. The leading edge today of lean construction is target value design and choosing by advantages, which is a very sophisticated way of making choices. The rule is decisions must be made on the importance of advantages. I've sort of spoken too fast. This is an example of a target value design curve from a hospital that was going to be about $1 billion hospital. They set the target cost about $150 million below that. That's the zero line there. And they began estimating it, and they estimated a few trades each week. And as the time went by, you can see that the cost of the project began to come down, down, and down. And then once it had met the target, a surprising thing happened. It kept going down because people were in the habit then of looking for new opportunities for ways to improve the performance. So that's a good story about the idea of target value design. All right, now let's look here. This is about choosing by advantages. And I'm going to use a canoe advantage. Choosing by advantages was developed by Jim Suhr, S-U-H-R, and somebody sent me an email, and I'll be glad to connect you with some materials about that. This is a very important development. Decisions must be made on the importance of advantages. So here we have a nice canoe. It's a lovely canoe. Let me tell you about that. It's a relatively short canoe. It's not very heavy. It holds two people comfortably, and you see it has quite I'll say a curve from front to back. So this is a kind of canoe that turns relatively quickly in the water. And so I would say, looking at that canoe, it's the kind of canoe that you might want to take down some fast water in a river, and that it has a bar across there that you can put it over your shoulders and carry it when you have to portage around things. And two people could take enough material in that canoe to go out and spend several nights going down a river and camp along the way and have a lovely time together. And they could maneuver nicely in some what might look at first like terrifying water. The next picture is another one. It's another canoe. This is my canoe here. This is my canoe. It's my wife in the front, my daughter in the back. You see it's longer. We can hold 4 people. It's also relatively flat across the bottom. This means that it goes straight very nicely, but it's more difficult to turn. Where I live, there's a lovely stream that's basically flat water. It's a wonderful place to go take a couple of our friends when they visit. We put a bottle of wine and a barbecued chicken, and we float down the river there and stop at a lovely table along the way and have a fine evening together. We've done other things in the canoe, of course, but the difference is there are 2 kinds of canoes. Now, the question is, what kind of canoe should I get? Well, it would depend on what are the advantages, which canoe offered the most advantages to the use you were going to put them to. And so money is not an advantage. That's an interesting thing you can look up and understand later. But so choosing by advantages dramatically improves the quality of decision making, particularly in the design phase. And I urge you to look into that. All right, so here's a kind of summary. I'm claiming that lean construction is, the common sense of lean construction is replacing that of traditional practice. Our strategy today is optimize the project and not the piece. And we do that, as I've suggested, both in our planning meetings and when we are fortunate to be in target value design, even in those circumstances. And so there you see, in a lean project, we would likely have commercial terms which were an integrated form of agreement, sort of all for one, one for all. Our operating system would consider activities, tasks, flow, and value. And so particularly flow, the big thing that we developed first was focus on improving the predictability of workflow. And so we've changed the nature of the operating system. And our organizations are different in that they swing more easily between central authority and distributed authority. So you have collaboration going on, the synergy of people working together, and you still have the authority of the project manager, although the good project managers are much more collaborative and interactive. So we have a new and coherent common sense. The three sides fit together as they fit together in traditional practice. But here the strategy is optimize the project and not the piece. Now, so it's a new common sense. And I think what else has developed since we started this adventure is the wide use of computers in design. And many people use the term BIM, Building Information Modeling, but I think that underestimates the function of computers. And so I like the term digital project delivery, which can include the management of logistics, the management of quality along the way, the management of the cost, all of the things that happen there together. We're now, I'm looking for my iPad here, more and more finding people in the field with iPads using that as a way to do their work and to make sure they understand where the logistics are and what the thing is supposed to look like, all of that put together. So I'm making a claim for digital project delivery. I stole that line fair and square from a man named not Kahneman, a man who, if you need to know, I'll send you that back. Our strategy is optimize the project and not the piece. All right, a summary. In traditional practice, I've just unfolded that triangle. In traditional practice, our organizations are hierarchical, and siloed, typically by trade, and we have a command and control culture. Our operating system is CPM centered, that is activity centered. It relies on specialists and drawings. Our commercial terms are typically lump sum, low price, and this leads to local optimization. So that it's a coherent system. I'm not saying it's bad. I don't think it works as well as the lean one. And so we use the same triangle, and now we add in the lean construction, and we're saying in lean project delivery, we have collaborative, flat organizations. We work on building consensus, and we're promise-based as opposed to authority-based. We focus on predictable lean flow. We use digital project delivery, set-based design, carrying forward a number of alternatives, and then target value design to choose among them. And we I have choosing by advantages there as a tool for how we actually do some of the work. And our commercial terms are entrepreneurial. We're all trying to figure out a way to take some great good steps forward in our project delivery, delivering to best value as the client understands it, and we're looking at project and global optimization. I think perhaps that lean construction is pointing the way to something we need to learn at the global level. We're having a very difficult time optimizing at the project level. Optimizing at the globe and thinking about global warming is a whole nother scheme, and so it's much more difficult, much larger. And so I think maybe that our lean project delivery is giving a place to practice those sets of skills that we'll need to make sure there's a planet here for my grandchildren. All right, so 5 big ideas. Sutter Health developed these 5 big ideas. They were the first owner to take this seriously. They've done $6 billion plus of work on these protocols. Very small number of disputes. They've come in well under their budget for the facilities they bought. The 5 big ideas were collaborate, really collaborate. Second one was networks of commitments, understanding the project as a network of commitments. Tightly coupling learning with action, optimizing the whole, not the piece, and increasing relatedness, how we understood one another. 2 more slides and we're done. So let's talk briefly about implementation. Traditional practice focuses down at the bottom left. It focuses on people or companies and on control. We try to control people and we try and control companies. Lean construction focuses on operating systems and learning. So you have them sort of at the opposite end of this 2x2 matrix. And it would be nice if we could just go from current practice to lean project delivery. You know, we're here today and we're there tomorrow. My experience has been that doesn't really work very well. And so in some sense I'd like to think there are 2 other paths. Some companies decide to go into learning and they really learn a lot about it and then they begin to take action and change their operating system. Other people plunge right into the operating system, try to make the workflow more predictable, and then they begin to learn more things as they work that. So there are 2 paths that people follow. I think the very best thing to do is to make a copy of this matrix and fold it along the diagonal line and have the 2 paths, the learning path and the operating path, in a way talking to one another as you go forward in the company. You may have to think about that some before you go. So I wanted a good international case to close with. We've done lots of work on refineries. We've done lots of work in very complicated, complex projects, very large projects. Intel is one of the maker of computer chips. I probably have 5 of them within arm's reach right here. And I began to think about what closing example should I give? And I'm going to give you my favorite. My favorite is from Ismail Adamu. Ismail Adamu is an engineer in Nigeria. He lives in the northeastern part of the state where the Boko Haram is quite active. He's a very courageous man. The government of Nigeria decided to build some government housing in that area, and they decided to have 300. They were going to build 300 homes. They were going to bid those homes out into packages of 50 homes each, so there were 6 packages. Ismail bid for and won one of those packages. His 50-house contract had a 120-day schedule, and he used a 90-day plan himself, using reverse phase scheduling, or pull planning as we're calling it. He broke his team into 7 to 10 person teams that worked in small units together. He completed all of his all of his houses in 72 days. No other contractor had completed even one during that period. And I love the line. He sent me the photograph of him and he told me his experience. And I love the line there at the bottom. He said, "The results were much appreciated." So there you have it, 37 minutes, 11 seconds. I hope this has been a useful introduction for you, and I wish you well in your conference. And if you have questions, my email address is, I'll send that so that you can correspond with me later. I wish you well. I'm sorry I can't be there. I was fortunate to spend about a week in St. Petersburg a couple of years ago. My wife and I had a great time together there. We love the museums. We love we just had a great time in the city. And I wish we could have come to the meeting there in Moscow. And one of my wife's great urges is that we do the Trans-Siberian Railroad sometime in the future. And maybe that will happen, and maybe we'll get lucky and meet some of you there. Best wishes. Thanks a lot. Goodbye.